Here to discuss how to meet AI's growing infrastructure demands, please welcome Chris Sharp, Chief Technology Officer at Digital Realty, Grace Coe, Vice President for Government Relations at Ciena Corporation, and John W. Kuzin, Senior Vice President of Spectrum Policy and Regulatory Counsel at Qualcomm. The conversation will be moderated by Stephen Kent of the Consumer Choice Center.
We'll waste no time. I know folks in this room, we all face a monumental task in the years ahead, which is for cloud, semiconductors, data centers, and network providers to jointly scale up all together for the global digital infrastructure to meet the demands of AI and other emerging tech. And on this stage, we have an incredible group to give you some insight into both the physical and invisible parts of scaling up that process. You know them all, John Kuzin, SVP at Qualcomm. We have Chris Sharp of Digital Realty and Grace Coe of Ciena. Thank you, everybody, for joining us today. So let's do a little bit of future casting. Let's start with what is coming. What are the technological or process innovations on the horizon that you are most excited about, and what is holding that back from being realized today? If we could go on down the line, that's a great place to start.
Great. Thanks very much, everybody, for joining us today. It's a pleasure to be here. Pleasure to talk to you about what Qualcomm is working on. Qualcomm is working on both ends of the AI enablement spectrum. We have a data center business, and we're also making massive investments in on-device AI capability. So what on-device AI capability is, having these devices, such as the smartphones in your pockets, or even watches and any other robots on a factory floor, for example, being able to autonomously run AI. And by having this capability to have on-device AI running, it is much more power efficient. A lot of the intelligence goes into the device and doesn't need to go into the cloud, so it's more private and more secure. It's also a lot more power efficient because you don't have to involve network resources. And the response is immediate because it's occurring on the device. That being said, both of these capabilities, data center growth and on-device AI, are going to have to work in concert. And in order for AI to scale, you're going to need to see both grow. And we think it is essential also to connect that with the rollout of 6G. There's no doubt that AI is going to greatly increase the network demands. So we're also working on enabling 6G, and 6G will be essential to enable AI to scale as well.
Yeah, I couldn't agree more. Can you hear me?
Nope.
I don't know. I think you're out.
Testing.
There you go. We got you.
Yeah, couldn't agree more. And I mean, just building on it, just to give a simple framework how to think about what's coming and what's next. There's three horizons we've always watched, right? There's software, hardware, and power. And if you watch those, you can kind of break down a little bit of the noise. So starting with software, I think with some of the new software advancements coming to market with agentic and some of the reasoning that's already been deployed, you're going to see a lot of this innovation really require a different type of infrastructure, but you're going to see 10x the proficiencies in software across the board, either on the device or in the data center and even in training. We mostly focus on inference and how inference is coming to market. So that software evolutionary curve is something that's near and dear, not only to our hearts, but our customers. And after inference, there's monetization of AI. That's a critical factor. And so we're always watching how to allow that to happen seamlessly as technology evolves. I would say hardware is phenomenal, right? Not only the hardware of the GPUs, but the hardware and how you're starting to cool and do the electrical distribution for some of these systems. And that will happen in multiple places in the metro. And I think that's something that we're always watching in how the hardware is going to be evolving, because right now you're looking at about 8 kilowatts a rack. We're way into the 3-digit per rack, rather simplistically, with some of the largest hardware manufacturers out there. So it's contemplated in the innovation that you'll see a 1.5 megawatt rack in the not too distant future. That takes a very, very different type of infrastructure to support that densification of power. I would also be remiss on the hardware side just not to talk about the interconnectivity. So as you see AI start to come and mature over a period of time, machine to machine, any amount of resource you provide it, either power or connectivity, it utilizes all of it. So just think about that. You'll see 10x what we've seen over the internet today really starting to come together. And so I actually coined a piece about 6 months ago, a little bit longer, called private AI exchanges, and the need for optical high throughput connectivity to allow for a different type of access to this software, because it's absolutely required for you to get the true benefit out of your investment in your infrastructure. Last is power. Power is the #1 constraining factor, not only power generation, but distribution. So we're always watching around the grid advancements, but then also how can we do new types of power generation, which I think we'll be getting into a little bit later today around SMRs and even some of the thorium reactors we've all been probably reading about. But power is another critical element on the generation and the distribution as well.
Well, that's fascinating. And thank you for mentioning interconnects, because that's one of the things that Ciena is incredibly excited about. Frankly, so we just got done actually debuting our 1.6 terabit per second WaveLogic 6 platform. I mean, that is a mind-blowing speed for both submarine cables, but also even down now to the interconnect between data centers, and ultimately now between racks of servers and between servers, because that is the kind of bandwidth that you're going to need. Continuing to scale that kind of connectivity up, which is what Ciena does, is going to be critical. And I actually just want to answer on a very concrete level, Stephen. I really want a robotaxi. And I really, really want that robotaxi, not to kill me, but also, so I kind of ultimately, this is the kind of data center, this is the kind of infrastructure that is actually going to be enable that to make it really live, and it doesn't leave out spectrum, John. So that's going to make you happy.
No, I love the range of insight here, because we have chips, we have data centers, we have optical networking and subsea cables. I mean, this is all the different ingredients that you need for the next chapter in tech and innovation. And so I think of AI as a double-edged sword. Of course, it is a huge drain, or it requires a lot of energy. But it also has the ability to help give us the tools in order to solve that. So how is that sort of virtuous cycle playing out right now, and how might it change?
Oh, is that to me?
Yeah.
Sure. It's incredible how rapidly ChatGPT and the large language model learning models have just revolutionized the way we interact with knowledge already. It is incredible how much is already changing, and I think it continues to learn. How is it revolutionizing the way? I can think in particular, from Ciena's perspective, our own, I think, business model, the way we think about where connectivity is going, has changed significantly. I don't think anything has changed the way telecommunications networks are deployed, are built, are designed in the way that AI has. The cloud did not change it this way, but now we are thinking consistently about not just serving the large population centers, but actually starting to get to bringing that kind of ubiquitous mesh of connectivity all the way across the nation.
Yeah, I couldn't agree more, Grace, because I think one of the things we've always looked at is training within the four walls of the data center required ultra high throughput, but now it's beyond those four walls.
Right.
And just you talking about ChatGPT, text to text, it's very minimal throughput, right?
Right.
But bimodal is everything. Once you get video, once you get real-time interactive video, like with some of the recent announcements, Gemini, where you're actually using your phone and you're communicating in real time, that creates spectrum, that creates high throughput, but couldn't agree more.
Right.
Chris, on the data center front, because we were talking a bit about this, and there's a lot evolving in terms of power density, and are you seeing a shift in demand between traditional enterprise models and sort of the ones that are actually going to support AI? How rapidly is that changing? We're in Northern Virginia, DC area. There's a lot going on.
Yeah. It's a bit of both, right? It depends on the maturity of the enterprise, and I'll kind of cut the market in two simplistic lenses. Hyperscalers, it's all about AI, right? And what's nice about it is you do have, in this local market, one of the largest availability zones in the world. So there's a lot of critical infrastructure here. AI is an and not an or. So they're embedding a lot of AI infrastructure into their existing infrastructure, and that's what's represented with the likes of Copilot, who is here today, where they're augmenting a lot of those capabilities and giving you more benefit out of the existing infrastructure that you're already utilizing. So that hyperscale perspective is absolutely, they're bringing it in. It's at I would say, the upper ends of density. It's not only the total capacity demand, and that they're bringing to market, because as inference starts to mature and more individuals are utilizing these capabilities, you'll see a massive step up in inference capabilities, but then also within the data center, the individual racks. So you can see like an 8 to 10 kilowatt rack like I referenced earlier, but you're going to start to see these 100, 150 kilowatt racks come into the market. So that's one end of the spectrum. With enterprises, it's an amazing story, right? And we've been working with a lot of enterprises around data gravity. So data feeds everything. It feeds all these algorithms, which are represented as artificial intelligence or AI. So that data gravity, we've worked with a lot of customers on their connectivity. How do you bring that data together and build your own private data ocean? A lot of individuals want that data to be private. That's all of their critical core infrastructure and core intellectual property. So that privacy of that data, we've all been on that journey for some time. Now what they want to do is bring in their own algorithms or their own infrastructure called AI to run algorithms against that data set and make it actionable. Some are much further along in that journey. Like we have a great case study with Gefion and the Novo Nordisk Foundation in Copenhagen. One of the largest, what Jensen coined, it's the largest DGX pod inside of Europe today, but it's doing a lot of pharmaceutical research. He actually coined it a center of intelligence. And so we're pretty excited about that enterprise journey being at a larger enterprise, but what they were able to do with their private data set and bringing that density and that capability into that market. So we're seeing these hot spots come into the data center where you have to have a design to support that variability, because remember, 8 to 10 kilowatts, you're jumping up to triple digit kind of power density. It takes the variability and different types of tool set to do that. And I've been in data centers longer than I care to admit. I've been at Digital Realty 10 years. We have a long eye in not what you need today, but what's going to be that demand over that 1 year, 2 year, 5 year horizon. And so being able to align our capital allocation to that customer perspective is absolutely everything. But we're definitely seeing a lot of enterprises wanting to do private AI and really trying to remove the complexity out of the connectivity and how they can utilize this infrastructure, because unfortunately more of these AI deployments today are science projects. And so we've been actively working with the largest providers out there today to build SKUs, repeatable SKUs, so that you can buy a simplistic outcome, not just a bunch of technology and have to cobble that together on your own behalf.
Yeah, picking up on the point that he just made about private AI and edge AI, keeping the data generation at the edge is one of the benefits, and it's more secure and private if you don't have to have a lot of this sensitive information stored in the cloud. So by enabling edge AI and on-device AI, you keep the data close to the user, and it also plays into exactly what he's saying, is you have these local clouds of AI capabilities. One of the things that I'll would invite you all to go visit Qualcomm's booth over in that direction is we actually have demonstrations of AI capabilities that run entirely at the edge, entirely on the device. These are demonstrations of services that we're helping Aramco in Saudi Arabia provide, where you can essentially have on a local device the entire user manual for a power plant. And you could use this capability to look at smoke coming out of a receptacle. And not only could you be told, hey, that the amount of smoke coming out right now is actually a little bit more than was coming out yesterday, or there's no smoke coming out. There's a need to investigate, send a tech, and then the tech would go on site and be able to address that issue all locally. A lot of the capabilities that we're enabling for Aramco literally run without any connection at all to the network. That being said, network connectivity is obviously critical. From our view, a lot of the training will be done in the cloud, but by having these capabilities locally, you really are able to have these new user models that never before been, we've seen.
Grace, you mentioned network connectivity. That's
Sorry,
yeah.
I was just going to add in there, John. Actually, and you're not running that on Wi-Fi, right?
No.
Right, you're running this on 6G on a private wireless connection, right? And we're not going to risk something mission critical like that on a Wi-Fi connection. And that connectivity to the network, now Ciena's not necessarily involved in the wireless, in the private wireless, but we certainly do deal with we deal with optical connectivity, so that's fiber. And we are running those connections back to the inference engine, back also to the training engines. And that's one of the things that we were just chatting about. Connectivity enables you to architect your data centers in a way that allows you to make the most out of your current constraints. So, for example, a lot of training data centers are now being built in more power-rich areas away from human beings who are getting a little more heated up, as Stephen mentioned in our earlier conversation about data centers in their neighborhoods, right? So they are primed to be placed because they're latency tolerant. There isn't as much issue with actually having those data centers in those areas. And places like Alberta that have locked up energy because they're not able to move some of that oil and gas out via pipeline, and naturally cold climates are trying to position themselves as good places for those kinds of deployments. But they also have to have connectivity, obviously, back to the edge, back to the inference data centers, which are much more latency sensitive. And so that kind of immediate connectivity, that high speed 1.6 terabit per second, or actually at this point it's probably more like 800G, but that kind of connectivity is critical. Additionally, going back to the edge, that wireless connectivity is also critical to to manage a factory floor.
How do we actually get bandwidth up to where it needs to be? Latency going down, bandwidth going up. I live in Northern Virginia. There's data centers being built in every single direction. It's a very hot button topic, like you mentioned. I imagine that's part of the solution. How are we actually going to achieve it, and how do you talk to normal people out in the world about it?
Do you want to start? Or
Yeah, data centers.
There's a couple pieces to it. So one of the things we've always done is we go really slow. Right, and we master plan sometimes 5 years out when we're working with a lot of the communities that we operate in around the globe. Yeah. I think that's an important element. And so we've been long-standing customers inside of Northern Virginia market because it is an epicenter like nothing else on earth in the amount of infrastructure and the amount of connectivity required for that. Part of that master planning is working with utility operators, and I think this is where there's a bit of contention where showing 2, 3, 4, 5 years out, we work with these utility operators so they understand that demand. And on their side, we're also very good stewards. And once we draw down and show that demand, we actually draw it down. And so that's where there's a lot of flack and concern in the markets today that as you build out this infrastructure, it needs to be utilized so that it's a much more efficient environment for everyone. I would also say a part of the master planning, just to link it back to some of the connectivity, are right-of-ways. So we operate almost 4 campuses in this market alone. So these right-of-ways, we've worked with the municipalities to be able to allow for bulk conduits to be interconnected between these facilities. Because it's not uncommon to have hundreds of thousands of fibers between 2 separate environments just to allow those 2 environments to fully be utilized from our individual customers. So those right-of-ways also allow for establishing, one of the things that's very frustrating in this market, because having talked with a lot of the communities, is that the road is always being torn up. And so one of the things we always try to do is do these bulk conduit banks where you can have upwards of 30, 40, 50 conduits being built out into a single environment. And that'll give you like a material amount of runway so that you avoid that overall connectivity piece. But then it comes down to the power and the way the power gets distributed within the utility operators. One of the unfortunate events that happen here is there's a FERC and a NERC test where the resiliency of the grid. And that's where we're always looking at when we come into an environment. We actually have infrastructure where we can do demand response. So at peak utilization, when there's a concern around the overall market demand, and sometimes it happens with different types of weather scales where it's hot or cold, we're able to actually bring on our own backup generation to be able to shave those peaks. And that helps the overall community to avoid any kind of brownouts or anything like that that could be an impact, a safety impact to the overall community. So just working with the communities and looking at it long term, how do you really respect the environment that you're operating in? And quite frankly, we've done a tremendous amount of investments for the overall transmission lines and transmission substations just to ensure that that resiliency and that scale is met, not only from the data centers, but the broader community. And the last I'd be remiss not to speak about, because you did reference it earlier this morning, is water. We take that seriously. It is a scarce resource. I've written many papers on what we do with environments where we can operate with no water, or with environments like we operate here where there's a lot of gray water. And this is water that wouldn't be utilized by the local municipality. So finding that balance and utilizing those resources in a very constructive manner is everything to us, because in this market, you may be flying in or out of DC. If you fly out of Washington Dulles Airport, you'll see off to the right, there's a gigawatt campus that we're building right now adjacent to the airport. again, that master planning allows us to build these things in environments where they're not in neighborhoods and they're not buried into the overall community. We're really looking at spots where we can build out in a holistic fashion and going forward. And I think the last piece I would say, because it's often missed, is that just think about the infrastructure that's represented in this room alone. I don't think people have an understanding of the scale of data center capacity behind each and every single one of these products that you're looking at or capabilities that you're thinking about, the amount of data center capacity that's required to support that. So it's a critical piece of infrastructure, not only for our work lives, but our personal lives as well.
We were chatting before we came up here. We were asked, are we going to still need more data centers? Are data centers going to continue to grow going forward? And I would say we're still in the very early stages. Data center growth is going to continue, but you could almost look back 150 years ago when the phone system was being rolled out. When a community needed connectivity to the phone line, they put a central office nearby. And those central offices grew and they spread across America. And then it was about 100 years in for where that real estate began to shrink. The different switch generations, then there was finally put in a 5 ESS switch from AT&T where you could literally have 8 floors of a central office be run out of a single switch. I think we will get to that stage in AI where the data centers are going to stop growing at the crazy rate that they're currently growing at, and it's going to be critical that to enable that, you're going to have this distributed architecture for all the reasons that Chris just laid out. It's more power efficient if you can run AI close to the edge. It's more secure, and it can be done quickly, and it will allow AI to scale.
Can I add one more note? I'm sorry. This is an exciting conversation. Can't help myself. And this is something that also, I think, equipment manufacturers, optics manufacturers, of course, are also thinking about. We have been able to, this WaveLogic 6 platform that I mentioned at the beginning is actually able to increase the bandwidth, double the bandwidth, frankly, within the same footprint and the same power envelope. So those are the kinds of advances that they continue to work. They did this by changing materials in the chip and then continuing to force additional, changing the way that they did the photonic algorithms. That has all produced, and this took a long time. It was hard work, and other people will catch up, but that is the kind of effort that people are doing because they hear what their customers are saying. We don't have room, we don't have power, we need to continue to grow our bandwidth, right? And so that is the continued innovation that is actually driving this here in the United States and North America today.
Chris, I want to shift towards regulation because everybody here is going to face in this room the patchwork of regulations both in the United States and abroad, and it is going to continue to be a problem for everybody's government affairs departments and compliance. How is your organization handling this issue with AI, cloud, and telecom regs?
No, 100%. And so as you can hear on this panel today, nobody builds alone, right? And unfortunately, the data center is the epicenter of integration. I mean, everything comes together, and it's at the ends of the spectrum, right? We're in connectivity with different types of density requirements, different types of floor loading even. Like some of these racks are getting extremely heavy.
Right.
So one of the things we're always doing is, again, working with our municipality, working with the different regulatory bodies on a longer term view of establishing what we would see as, quite frankly, standards. The lack of standards makes it even harder for a lot of these regulations and different types of rulings come down even from the local municipalities. And I think one of the things we've always done is try to lean in and just educate on design once and build many. And so we try to show some best case scenarios from some of the local, and regional offices that we deal with. It takes us around an average of 2 years to bring a data center to market. Sometimes some of these permitting and processes that are put in place actually take longer than that. And so it's extending the timeline of our ability to, once we have entitlements and power, the overall permitting process and everything else is pretty, I would say, stagnant. And so one of the things we've always looked at is investments. Right? So you have to invest in these local municipalities, investing in education, investing in what are the policies that are going to not constrain, but actually enable more innovation. Because at the end of the day, a lot of the work that we're trying to do around policy and different permitting processes allow for this type of innovation within reason, right? So the policies exist and the permitting exists for safety mechanisms. So we're absolutely supportive of that, but you really have to lean in on how many other environments have we seen throughout the globe and learn from their best practices so that they can be afforded to every community, even like the local one we sit in today?
Yeah, permitting is such a common cry when it comes to any sort of infrastructure development. I would 100% echo that as a real issue. Certainly in the deployment of especially when it comes to something like telecommunications networks, right? Certainly with power, and granted, I understand that AI infrastructure does involve a significant amount of power, but in a lot of instances, telecommunications lines are relatively inert and don't have as much of an impact on the environment as, say, a power line, a pipeline, whatever else. So I think there does need to be a right sizing of the permitting regimes that need to go into doing these kinds of works. And there are multiple regimes, and they can take upwards of years. In fact, I used to listen to this one. This one wonderful horror story from somebody who was trying to connect a fiber line somewhere in Mississippi, and there was one stretch of federal highway they had to go by. It was a 150-mile fiber line, 8 miles of going through a highway area, and they had to wait a year and a half because there was an endangered species nearby, the gopher turtle. They had to go and dig for gopher turtle turds when they were going off to lay this line. They dug for the gopher turtle turds, found none, submitted the findings to the Fish and Wildlife, I think, agency. They weren't able to process it in time, so they had to wait to deploy. The permit, the environmental finding lapsed, and then they had to go off and dig again to find another, to do this all over again. These are the kinds of delays that we really can't afford to handle as we're trying to build for the future.
Well, Grace, then how do we avoid that kind of thing happening? Because these delays are going to happen in all sorts of localities. Do you have any best practices from your experience in government affairs in how to talk to government officials, city councils, when it comes to supporting y'all's business?
I think the first thing that everyone needs to understand that there is a buy-in. Government is about multiple priorities. Government has to do 500 things well. They have to protect the safety and health of their citizenry, but they also have to create a foundation for the next economy, right? And so recognizing that they have to do all of these things well means that they're going to put priorities into, they're going to figure out what the risk analysis is when they go forward and start to figure out how they're going to actually move the permits forward. That's the best they can. That's the most they can do. Staffing appropriately, maybe using AI to actually help figure out some of these issues could actually speed some of the processing and the analyses faster.
Yeah, we're actually using a couple firms here in North America that do AI analysis against what the permit requires and trying to expedite the approval process.
And standardizing those permittings.
100%.
Across the 50 states. I mean, running and mutual recognition agreements in terms of findings, et cetera. I also wanted to give a nod to standards. Those are also extraordinarily important. And I know, John, you spend a lot of time on that as well.
Chris, what are some regulations that don't exist yet that might be helpful for this sector to succeed? I know it's a big, big question. You can narrow it down in any way you'd like, but help government officials and lawmakers get a little creative here. What do they need to actually write up?
Yeah, I guess there's two ways to look at that, right? Where I think there has to be new regulations and a new like revitalized view of power generation, right? Like I touched on it earlier today, like SMRs and things like that. I think there's an arcane way to look at, hey, all reactors are the same, and this new type of modularity that's coming to market where there's a bit of apprehension around, hey, these were bad, these can't be good. So leaning in and actually revitalizing the way that you look at how some of this comes to market, I think is absolutely a prerequisite. It's a prerequisite not only for the United States, but it's a prerequisite for the world. I mean, one of the things I also wrote about here recently about thorium reactors, old technology, now revitalized. I mean, some of the promising nature of how we can bring power to market and quite frankly, make power more of an enabling factor, I think is everything. I think one of the things I often get directly asked about is like regulation around AI. I think one of the things that's concerning to me is because it's so amorphous and it's growing so quickly, I'm always concerned about some of the regulation that I've had purview into viewing that it'll really stifle quite frankly, the innovative nature of the way that a lot of these capabilities are coming to market, I think we have to do a tremendous amount of work on education. Education to the consumer, education to the business on what is the actual risk associated with enabling this AI capabilities throughout all of your business or in your home life. You have to go really slow with that. So there's some new regulations that I think are required because you just can't let everything go out there and be the wild, wild west. But I'm always a firm believer of you can achieve regulation through standards, and those standards I think will help us be more efficient in being able to utilize a lot of the existing power that we have, and quite frankly, some of the software capabilities that are coming to market.
John, before we're out of time, I've been dying to ask you about the changing political climate, Trump administration, and how Qualcomm is thinking through the push for reindustrialization and all this talk about reshoring. And how are you factoring that into your capabilities with on-device and hybrid AI? Is there some synchronicity there between those goals and what y'all can do?
Yeah, that's a great question. So AI provides an amazing opportunity in this age of reshoring businesses to America to provide efficiencies that we've never seen before. Just look at a factory floor, for example, where you have a bunch of robots that can be operating autonomously in a product fulfillment center. What AI inside of these robots at these edge devices can do is allow them to go about their business, and even if the power goes out, even if there's no connectivity, these autonomous robots can continue to do their work and very efficiently. And then you could also use AI to monitor the robots and say, that robot is moving slowly, we need to address it, it's actually causing inefficiencies on the factory floor. And I think that is one of the greatest benefits, and also it's a real opportunity as we look to do more manufacturing in the US to really take advantage of AI and design these efficiencies in from the ground up.
Love it. Now, at a conference like this, and we'll wrap up on this question, I want to hear from all of you on this. Everybody here is interested in networking and collaboration and trying to learn and grow things together. So for people to get in touch with you, what are you looking for in terms of capabilities and resources, whether it be human, capital, or technological? What are you searching for right now in this room to advance things in your sector? Grace?
Yeah, human capital, energy. I think one of the hardest things is, like, data centers are cool now. Not too long ago, nobody wanted to work in a data center. I traveled around and I speak to a lot of different colleges and different, also mechanical HVAC schools about coming into the data center and how it's a rewarding career, right? I mean, so many of the media has portrayed the data center as like this deep, dark thing that you never wanted to walk within. But human capital, I think, is everything to us. And I think also, always coming to these types of events is the right types of policies that enable the outcome we're looking for. And I think the collective energy in this room, AI is going to be very, very, very disruptive. And so I always welcome individuals to get on the right side of disruption and find some comfort. You can't avoid it. It's not going to be going away anytime soon. But just really get educated on the way that artificial intelligence is going to be coming to market and how you can benefit from it. And so I think, one of the things, and I read a blog post and a bunch of research articles. Unfortunately, most of it's for a lot of investors. Being a publicly traded company, we spend a lot of time with the investor base on how AI is going to grow and impact the market. But there's also a lot around how you can learn and what you can do to benefit from some of these capabilities and how they're coming to age on how to change the way that we view work and the way that we view our home lives. So just being comfortable with that, I think, is everything.
Grace, anything you're looking for here today that people can bring to you that might be of interest?
Oh, no, I think, I tend to look at things from a government relations lens. First of all, let's just say a thank you to SESP for actually focusing on AI as a critical technology that is going to be incredibly foundational to our economy. And I think they're focusing on it with a good reason. This is going to be with a good reason. And I really applaud them for actually taking the time to actually really try to explain this to government policymakers as well. What we want with government policymakers and with all the other stakeholders, civil society, academia, and other members of industry alike, is real real dialogue on how we are going to make this work, how we are going to bring this safely to people, and how we are going to continue to power a sustainable AI ecosystem going forward that is in line with the United States values, et cetera.
And John, just to close us out, Chris
Yeah.
mentioned human capital.
I would say we all need to recognize and appreciate the fact that it's the top of the first inning and there's maybe one out. So the game is still being played. And what am I looking for here? I would encourage all of you to walk the floor, continue to talk to people, see what tools are out there. Feel free to reach out to Qualcomm. We're happy to chat with everybody. There's a lot of opportunity, and it's a very exciting time. And I too want to, thank the SES group for putting this on. This is a great event, and thank you for moderating.
Absolutely. Thank you, everybody, for coming out today.